Okay, I'm here with Jonas on the Flat Group booth at Data Center World in Frankfurt. Just be good to understand what it is you are showing here. Do you have any new solutions, any messages you're sort of promoting? Clearly the data center industry is booming, AI is on everyone's lips. Just, what is it you're hoping to achieve here and what are you promoting?
No, thanks for having me, Philip. The interesting thing is that we're in Frankfurt, in Germany, because Germany is probably the second biggest data center hub in Europe after London, and it's growing massively. And we're proud to be here. I'm here with my team. We're based in Germany. Our head office is actually in Germany, so it's great. Now, in terms of what we're trying to promote, yes, you can see behind us the CDU that we make, and the good thing about CDUs is it's the bridge between the direct-to-chip technology side of things and the chiller, and that bridge is the CDU. So we're still very much on the infrastructure, the physical infrastructure side of data centers, making sure that the direct-to-chip liquid cooling works through the CDU. But it's not just that. You see, one of the things that we're talking to a lot of our customers about is that life cycle around cooling with data centers. So where AI comes in now is AI is all about capacity, right? Having not just the capacity for power, but the capacity to cool. And cooling capacity is now a competitive advantage for AI companies. And that's where we come in. The whole life cycle cooling, thermal management infrastructure. And that's kind of the things that we're talking to customers about today.
And in terms of the AI boom, I mean, I don't know how long you've been in the data center industry, but presumably for a while. So
30 years.
Okay, 30 years. So what we're seeing now, most people are saying it's never been seen before quite in terms of the uptick and the expansion being planned. Is that what you're seeing? Is this something unusual or just more of the same but on a larger scale?
I think it's more of the same on a larger scale in terms of technology booms. There was a time that you had the internet boom, as it were, then the content boom, and now you're seeing the physical infrastructure around AI boom, right? So what's new is the boom around physical infrastructure itself. So the chillers and the power and what have you, in the last 3 years, it's been a boom. Partly about digital transformation, where you had cloud, but now with AI, it's set to take off in a much bigger way than cloud did. And it makes sense, because we're moving to AI in every facet of society. It's becoming ubiquitous, whether it's in, AI in Facebook, content, TikTok, to factories, to universities, to every facet of work and leisure, AI is moving in. And so all of that has to be plumbed, all that data has to be plumbed somehow. And it's different as well. It's different in the sense that you don't just have simple traditional data centers, servers. You have high capacity servers crammed in a very small space, creating new challenges for physical infrastructure. But it is a boom. Whether that ends up being a bust is another argument, right? There's a lot of discussion about OpenAI and NVIDIA and the money flowing around, particularly in the US. But the reality is, whatever happens on the finance side, the expectations and the need for AI will continue to expand over the foreseeable future, 10, 15 years' time.
And in terms of the liquid cooling, again, the technology, I think mainframes used their way back in the 70s, then it sort of disappeared. Now people have been talking about it, but it seems like finally its time has come. And you're mentioning direct-to-chip. That's where we are now. Immersion cooling, thoughts about that, I suppose, How do you see that liquid cooling landscape developing alongside this AI expansion we're seeing?
It's a very interesting question, because the normal scenario or the normal thinking, at least let's say 2 years ago, was it's all about capacity. It gets to a point where the capacity problem for cooling with direct-to-chip will get to a limit. And then that's when immersion will come in and take it from there. But when I speak to some immersion cooling companies and guys, the impression is that the problem with that capacity ceiling within direct-to-chip is similar to the ceiling within immersion, because you still have to cool immersion to a certain point. And that's, of course, we want to talk about cryogenetics, which is another issue, right? You cool it to a point, And it's not that different to where you are with direct-to-chip. So if we ever got to that ceiling, which I don't think we will, because there's going to be new developments in CDU technology and chiller technology and free cooling anyway. But if it does get to that point, then we're probably at the very edges of what quantum computing can do, and maybe miss entirely immersion cooling, apart from with specialist applications. And so you might jump to quantum computing cooling, which is where cryogenics comes in. So we will see where we go from there. Whether it's from direct to chip to quantum to immersion cooling, still not convinced yet, as opposed to just bypass it entirely. But we'll see.
And in terms of the way the market's developing, are you finding yourself needing to collaborate more than you ever have before? Because you've got to talk to the server folks, understand what's coming down the line, the designs of data centers changing, etc. Just how important, I say, is it to have your sort of ears and eyes out there, understanding where this is going? Whereas once upon a time you've kind of thought, yeah, we know what the data center market is, we'll develop this because we know that's what they need. Just how easy or not is it to anticipate the market demands?
Well, it's a very good question. We're moving, and for a while now, we're moving as a vendor into this ecosystem space, right? Where you have lots of stakeholders that need to communicate so that we can make decisions accordingly. And so you're right, from investors of land, all the way to operators, but then to the chip manufacturers like NVIDIA that we have conversations with, to Ashway that we're part of, to data center associations and around Europe and even the globe that we have to keep on talking. Open Compute project, there's a number, even lobbyists, there's a number of various stakeholders that we all have to communicate to get it right. We can't be a lone wolf where we think this is the solution that's going to work. Let's go. It doesn't work that way. So, across the board, from contractors to even competitors, it's having those conversations so that we know what the future looks like rather than making strategic mistakes moving into the future. So it's very much what we do, very ecosystemic on all levels within our organization, from the technical guys to the supply chain management, to myself in business development, to marketing. We talk to all kinds of people to make sure that we get it right. Absolutely.
And in terms of the AI focus at the moment, is it mainly these big sort of gigawatt factories, AI factories, whatever you want to call them, or are we also talking about inferencing and more distributed, smaller but still high density workloads? What are you seeing as to that AI sort of landscape at the moment?
A bit of both. It's a bit of both. It all depends on the application. I think, inferencing, AI inferencing and AI factories they both have their needs and will both grow in parallel. The solutions in general are similar, but obviously it's specified according to, the actual project itself. But they're growing in parallel. The need for AI when it comes to physical infrastructure is the same. It's consistently growing. It's just that it's for different applications. I wouldn't say one is any more than the other. It's almost like how it was with traditional data centers. You had enterprise data centers, where a company has their own data center. You have co-location space, and then you have the hyperscale data centers. And they were all growing. I know there was some direction from the enterprise to the hyperscale to cloud, but essentially they all had their niches, and they're all growing in parallel, and will provide cooling for all three of them, but obviously different selections. Same thing with this scenario. AI inference versus huge AI factory versus specialist high-performance compute environments are all growing equally, but different applications.
And just back to the liquid cooling, how much at the moment, if you like, is talk and how much is action? Because obviously, the industry was reluctant to use it, and it's kind of being forced to use it, I get that, but in terms of the number of installations out there that are generally using these sort of liquid cooling, any ideas, or are we still slightly, in the next 12 to 18 months when all these planned data centers come online, is that when liquid cooling is really going to take off, or where is it at exactly, I suppose?
Well, I think there's still been a lot of design work, particularly in EMEA. I think you have to look at it regionally. So you've got obviously the US or Americas, you've got EMEA, and you've got APAC. I think it's taken off quite well in the US. But then they tend to go with a larger 5 megawatt and above on the skid when it comes to CDUs for liquid cooling. In EMEA, I still think there's a little bit of flux. at the moment, but I think it would certainly develop. If it does develop, which it is, it would be in a hybrid scenario. It wouldn't just be straight to liquid cooling. Liquid cooling, air cooling in a hybrid. And it may be that there's still a space for rear door cooling, heat exchangers, as you move into. But it will be a natural progression because it's all down to the density per square meter as such of servers. So that would be a natural increase, but it wouldn't happen just like that. There is that design element, which is people are not sure at the moment. Operators are not 100% sure which way they're going, but it would happen. In the APAC region, that's moving quicker as well. So I think US is the quickest, APAC, and Europe is slowly getting there.
And in terms of I suppose, the size of the opportunity, because everyone's talking as if, AI is the only game in town, but there are clearly a lot of so-called traditional data centers that can still do a job with, more standard workloads. So, and always with that sort of high performance stuff, it gradually filters sort of down the chain, but finds a point. So just your thoughts, I suppose, as to how far AI will encroach on more traditional data centers over time. Any thoughts?
That's down to the AI platforms.
Right.
So at the moment, obviously, you have work around your different servers, your web servers, email servers, what have you, which gives you your traditional data centers. And that's fine. And as AI increases, there will be a hybrid environment. Maybe you'd have, different sections within a building, different halls for traditional versus AI, fine. But at some point, the platform would be AI for everything. And so therefore, it will get to that stage, and that's it. So whether the AI inference or factories are working on everything, so whether it's a web server or email server or what have you, it just feeds into the workload that's ubiquitous, and AI manages that. That's not where we are now. AI is really down to specific applications, but that's where it's going. There's no point in saying far into the future that we're still having this hybrid, two-tier approach. The platform will deal with everything imaginable, and we'll get there probably in around 5 years.
And just finally, you mentioned the cryogenics and the quantum. How far away? Every day I get a release about post-quantum cryptography and all this kind of stuff. But is the reality we're talking 10 years before it really makes an impact?
I'll say at least 10 years.
Right.
And the reason why is that even when you have the technology ready, for it to become ubiquitous in the market, where the market itself embraces it and then makes it work for them relative to existing technology, in itself takes time. So if you remember, we had a digital transformation idea working very, very well, ready to go, but nothing happened for at least 10 years. In fact, it only became when COVID came that digital transformation really took off. But technology has been there ready to go for years before that. The same with direct-to-chip. Direct-to-chip has been here for a while. CDUs have been here for a long time, right? Yes, a lot of companies are now making it, but it's been around for a long time, the technology. It's only now that we're ready. It'll be exactly the same with quantum computing, where we're almost there with the technology. It's still a way to go. It's still very, very fluid. Maybe in a couple of years, 3 years or so, it'll be ready. And then it becomes another 10 years after that for it to become ubiquitous, where the business community takes it on and replaces existing technology.
So do you as an organisation keep a sort of watching brief on it, or are you doing some sort of technology projects to make sure that you're ready for it, or as I say, you're just aware of it there and sort of...
At the moment, we're aware of it. We see which way it goes and how it impacts our business strategy for the future. I think that it may be that because we're owned by Samsung, it may be that we, rather than start to look at developing it from scratch, we may see how things go, and if it seems to be something for us, then we can invest and go through maybe some form of acquisition. But again, that's for the far future. We see how things play out and how it impacts our future strategy as a company.
And we talked pretty much about AI to the exclusion of anything else. Is there anything else happening in the data center market that sort of causes you either sleepless nights or you see as an exciting opportunity, or is it pretty much AI is the only game in town right now for data centers?
Well, yeah, the big shift is AI, and what does that mean for physical infrastructure? Well, what you also have to bear in mind is you see a lot of our competitors around building CDUs like this wonderful product behind us, but And to tell the truth, it's still just pumps and heat exchangers and, and valves. The key thing that we are really focusing on is controls. Because you can have a very good CDU, but if you can't, translate the variable workload in a speedy fashion with what needs to be done at the CDU level, right, for the technology, between technology and the infrastructure level, then essentially you're going to degrade the workload. Yeah. You're going to degrade the AI infrastructure itself. And so having the right controls that can work very quickly is key. But what's also key is deployment, execution. You get all these CDUs, 5 megawatts, 3 megawatts, 1.5 megawatts, even higher than 5 megawatts, and you bring them all on site. How do you test them on site? How do you do your level 4 and level 5 systems integrated systems testing? Those are areas that differentiate us as a company from our competitors, rather than just we can provide the CDU. So you not necessarily have to look at the next big picture, but the picture that exists now, the big picture, how do you make that work? There's still a lot of intricacies around that, which we are really spending a lot of our time and investment making sure it works right.
And that's presumably maximum, because I know, with the power and the cooling, that there's a lot of talking about throttling a server, so they're not operating anywhere near.
Exactly.
And with the AI workloads described as spiky, etc. So it's not just, as you say, coming up with a bit of hardware kit, whatever. It's the management as important, if not more important, is it?
It is. It's as important because one feeds on the other, but it's tricky. It's easy to build this, tricky to get the right control software to do that. And the key thing is that, as I said earlier, that the capacity is essentially competitive advantage for these AI factories. You have two infrastructures, both the same power capacity, both the same infrastructure when it comes to AI in there, but one is not working as well as the other because of how the controls deals with heat, deals with the thermal capacity, as it were. That's the competitive advantage, not just power. And so being able to use controls to make sure you do not degrade your AI infrastructure is absolutely key, but it's not easy. So we're now moving away from just being mechanical HVAC engineers to being software control specialists to make it work. But also, how do you deploy and scale? Which the bottleneck is the physical infrastructure, logistics, execution. That is also key. So again, those are two areas that require a lot of thought, a lot of strategy, and a lot of execution.
And how easy is it to communicate that message, bearing in mind that most of the people you're potentially talking to are, as you say, M&E folks that perhaps don't have a great handle on, the software side of things and the intelligence and the automation, and maybe a bit nervous about it as well because they can see a world where, everyone's telling them AI is coming for your job. Yeah. So what sort of conversations are you having with these folks, if you like?
It depends on who you talk to. Like I said earlier, we've got a massive, stakeholder ecosystem. Yeah. And the people that we talk to that is interested is the senior executive within these co-location hyperscale companies. Because they don't really care as much about the nuts and bolts of the machine. What they care is we can get it on time. There is no delay in the project. It can be tested without any problems inside because that creates delay. And we can scale very quickly because their issue is around deployment, around scaling. So when you say, look, these are some of the issues that could help you solve those problems where you don't have delays and therefore you don't have liquidated damages or financial penalties you have to pay, or you're able to now compete effectively because it's up and running and it's not degrading your AI infrastructure, and therefore it's cheaper for you to run, and therefore more profitability, for example. When you have those conversations and they ask, how does that work? Then you start talking about controls, start talking about execution. Then they become very interested, if you see what I mean. As opposed to M&E, who just want to make sure that the project works fine, which is important. If you just tell them, listen, your project's going to be delivered on time, we got logistics, we won't make you look bad in front of your clients, great, they're happy with that. But I think if you're having conversations with a controls guy and another controls guy, they can knock themselves out, but the real value is what is it giving the project? What is it giving the company who is deploying those for competitive advantage? And that's where those conversations really start to add value.